What's up everybody, you're on GCSE and iGCSE. This is Revision with Daniel Dallas. It's all about circle theorems, circle properties, inscribed angles, central angles, and like similar stuff. So that's easy medium level. That's pretty short problem. If you want to have something harder stuff, just have a look and check it out. My playlist dedicated to circles. You'll find definitely there a lot of stuff. Now pause the video, try this problem by your own, and let's have a look at my explanations. Alright, so we need to figure out the measure for the angle BCL. So this angle is arranged by the chord within the circle, chord BC, and the tangent line ML. So for simplicity, I'll put the measure for this as angle X. So I'm marking this way. So let it be angle X. And here is the theorem, so make sure you know how to prove the theorem just in case for your personal, knowledge base. So this angle between the tangent line and the chord that touched your basically tangent line is going to be the same as inscribed angle supported by the same chord, or basically subtended by the same arc lengths than the points of the chord B and C. So this angle is also X. Okay, so we need to define basically the third angle within triangle. So solution for the A part is pretty easy. So you need to, from 180 degrees, subtract the sum of the rest two angles, 23 and 62 degrees. So if you calculate, so that's going to be angle X within triangle, and actually our target angle X, so I'll put X here. So let's have a look. Let's calculate 180 degrees minus 85. So the answer for that is going to be 95 degrees. So you probably might have an alternative solution. So if you first want to say that according to this theorem, this angle becomes angle 62 degrees. So you can also use the fact about ML as the open angle and just add 62 with 23 and with angle X to arrange 180 degrees angle, so open angle in that case. So solution will be similar to that, and you'll find out that the resultant measure is 95. Alright, so question B, we need to find if the O center of the circle, what are two possible measures for angle COB? Alright, so I just moved to the next slide for simplicity, and let's put point O. As you understand, because this diagram is always not to scale, so you might put point over there or within the triangle. For example, let's put this point here, let it be the center, and let's connect to arrange the central angle, which is in our case going to be the target angle COB. So I just put the pink color to denote that this angle is going to be the central and our angle that we need to find. Alright, so I mark this angle as Y, so Y degrees, and that means we need to define this angle. Alright, how to define this angle if your point O is beyond segment CB, beyond basically triangle? So we need to complete the following step. So the measure, we need to connect your central angle with inscribed angle within the circle. So that means if I choose another color, let's say this one, I can put, no matter where I choose the point on the circumference, so let's say here, it doesn't matter, to clearly show that we have another inscribed angle subtended by the same arc length CAB. Okay, so I put another letter, let it be D, and we know that angle COB, which is equal to Y, will be twice of the angle CDB. Okay, that's going to be 2 times angle CDB in that case. All right, how to find angle CDB? In that case, we can figure out the value for this angle using the fact that we calculated angle A on the previous, that was angle X, that we calculated is 95 degrees, so we can mark this angle is 95 degrees. And we know right now quadrilateral A, B, D, C is cyclic. So this is cyclic quadrilateral. So that means the opposite angles, angle A and D, will add up and give you the amount of 180 degrees. That's the property of cyclic quadrilateral. So hence, as a result, we can write that angle A plus angle D will form 180 degrees. So that means we can find angle D. In our case, it's going to be 180 minus 95. And that means we will come to 85 degrees. So we know that angle D right now is 85, so CDB is angle D. CDB, basically the same as angle D. And we know the measure, so that means for COB, our target angle, which is Y, we'll get twice the measure of that. So twice by 85 degrees, we'll get 170 degrees. So that's the first possible measure. So that's one value. But why you asked about two possible measures for angle COB? So we can discuss COB, the angle, as the reflex. So it means not Y, but 360 minus Y. So COB, another value for this angle, might be as COB. The second measure is also as 360 minus Y, because we're not clearly state which angle we need to actually give the value for. So that means the alternative measure is basically the complementary angle that complements your Y to 360 in that case. All right, so that means 360 minus Y will give an alternative measure for that, which is 190 degrees. So 190 degrees is from that side, so that means I'll choose this green one. Not the green one, let's take the blue one. So that means this angle is 360 minus Y, which will give you 180 degrees. All right, in case, guys, if you decide to put point O within triangle, okay, so you'll get the same measures, trust me, because in that case you'll have twice the measure of 95. In that case, that will give you 190 degrees, and another value for that will be 170 anyway. So no matter where you locate the point O within triangle ABC or outside, you'll have the same measure. That was pretty easy. It was based on cyclic quadrilateral. It was based on circle theorems. So I hope you like that. Hope I clarified some points and answer your questions that you probably had it before. So if you're new here, please subscribe and share in comments what you would like to expect to see in nearest videos. But again, due to lack of time, I have always a compromise between, and I need to split my time between physics, between different programs like GCSE A-level stuff and general maths and physics as well. So guys, you're welcome always. See you later.